Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun little geometry problem. So in this problem I have a rectangle with side lengths 10 and 20, and inscribed inside this triangle, or this rectangle, are two circles, and then we have a diagonal going from corner to corner of the rectangle. We want to find the area of the gold regions. So if you want to give this a shot, go ahead and pause the video. Otherwise we're going to jump straight into our solution. So what I'm going to notice first is the area of my overall rectangle is going to be 10 times 20, which is just 200. And I also can look at my area of my circles. So my area of my circle is going to be pi r squared. So pi times my radius, which my radius will end up being 5 because it's 1/2 the side length. So 5 squared. And since there are two circles, I'm going to have total area of 50 pi. So if I wanted to get the area outside of the circles, then I would do, so we'll call it the area of gold. So to get that gold area, we're going to take 1/2 of the region that's outside the circles, which will be 200 minus 50 pi. And that's going to give us our start. So our area of our gold region now looks like it's going to be 100 minus 25 pi. But there's a problem, because that's not the gold region. That's region 1, 2, 3, and 4, which is this guy down here. So our real problem becomes, what on earth is this region 4? So this actually isn't the gold region. This is the gold plus 4. Okay, so now we have the gold region plus region 4. So if we can figure out what region 4 is, then we're good to go. And that becomes the real battle here. So let's go ahead and write down our problem in a little bit smaller regions. So I'm going to redraw one circle. So this is 1/2 of our figure above. Sorry about that. So if we redraw our circle and a square, so I know that's not perfect, but really what we're trying to find is we're trying to find the area then. If we go, sorry, man, not on it. Okay. If we go down like this, so we're trying to find the area down here. So that region down there. Okay. So how can we do this? Well, let's go ahead and try to simplify this just a little bit. So let's look first at this triangle. So we can get the area of this triangle. So this area of the triangle is going to be, if I look at this, it's going to be going up 1/2. So it's going to be 1/2 base times height, which is going to be 5 times 10, which is going to be 25. So I have 25 as my area of my little triangle. But that doesn't help me too much yet. So I have a few more shapes I need to know. So I need to know what the area of this region over here is. So the green region I can get fairly easily, because by symmetry that's going to be 1/4 of the area outside of the circle but within the square. So what's that going to be? So that's going to be the rectangle, which is 10 times 10, minus the area of the circle, which is pi times 5 squared. So that's going to give me 1/4 of 100 minus 25 pi. And that's going to be, sorry, my 4 is a little messed up there. So that's going to be the area of the little green region. So to get the area of the purple region, I really now just need the area of this little circular section in here. So that's what we're going to look at for a second, and that's what we're going to be investigating for the next couple of minutes. So if I look at this circle here, I can draw some radii. So I know each of these guys is going to be 5. And now I'm going to redraw this little shape. And I'm going to do, let's look at some geometry real quick. So if I take this region and I subtract this portion that's in the circle, but I include this. So if I subtract that whole thing, so we're adding a little bit of extra. So I know I have a little bit of a problem right here. So because we're subtracting that, we're going to have to then add it back. So I'm then going to add back this little triangle. So now I have the red triangle minus the blue. We also have to subtract the green. So we're also going to do minus this little green section here. And if I do all of that, that's going to equal my little purple section down in the corner. Okay, and this is what we're trying to find in this section. So really, I just need to find the areas of these different shapes. I've already found this guy. I've already found this guy. So really, my question becomes, can I find this guy and this guy? So let's go ahead and look at those two shapes real quick and see if we can figure out a way to get their areas. Okay, so let's look at my little circle with the triangle guy. Drawing is not going well today. Okay, so little circular section. Good Lord. Okay, circular section here, coming up, coming down. Okay, so I know that this and this, these guys are both 5. So if I was to draw this, it's a triangle, and it's actually an isosceles triangle because I have 2 equal sides. So that means this angle, which I'll call theta, and this angle, which I'll also call theta, are going to be equal as well. Okay, so if I can figure out what that angle is, then I'll be looking pretty good. So let's look at my shape up here. So I notice that I have in this shape, so we're looking back up at this. So I have this straight line, and this is going to be parallel to this bottom line down here. So this is parallel to this guy. So if this is my angle theta, then that also must be equal to this angle right here, which is also theta. So now I know that theta is equal to this angle here by my purple region. So how can I get that angle? Well, I know that this side length is 10, and this side length is 5. So theta is going to be the inverse tangent, the arctangent, sorry, of 5 over 10, which is arctangent of 1/2. Okay, so I have an expression for theta. It's not the nicest expression, but it's something. So now what I can do is, let's look at this angle up here, which I'll call angle alpha. And I know that alpha plus 2 theta is going to be equal to pi, or 180 degrees, if you're not used to using radians. So that means that alpha is going to be equal to pi minus 2 tangent, negative inverse tangent of 1/2. And that gives me my angle alpha. Okay, so now that I have the angle alpha, this is going to be enough to get me working towards some of these other areas. Okay, so let's look at the area of a circle. So I know the total area of a circle. And if I were to extend this, then if I look at my area of my little boat thing, so my area of this guy is going to be alpha divided by 2 pi. So remember, 2 pi is 360 degrees. So I'm basically swiping out a portion of my circle times my total circle, which is going to be pi times my radius squared, which is 25. So the area of that whole region then, my pi's are going to cancel. It's going to be pi minus 2 arctangent of 1/2 times 25 over 2. Okay, so this is going to be the area now of my little boat guy. So now I have that area. So my final area I'm going to need to calculate is this triangle, this isosceles triangle, which is actually not too bad. So if I look at this isosceles triangle, so I know this angle is alpha, I know this side length is 5. So really, I just need to find my height here. So my height is going to be 5 times sine of alpha. So if I'm looking at alpha now, so let's look at this. So alpha is, so I'm taking sine of pi minus 2 tangent -1 of 1/2. Okay, so let's do some geometry real quick and kind of figure out what this looks like. So first off, if I have my angle theta, so my angle 2 theta is still going to be less than 90 degrees. So if I'm looking at 2 theta, or, sorry, if I'm looking at this angle, which is pi minus 2 theta, I'll notice that both of these guys are going to have the same y component. So these guys are both going to be the same sine. So I know that sine of pi minus 2 arctangent of -1 of 1/2 is going to be equal to sine of 2 arctangent of 1/2. So I can actually get rid of a little bit inside that expression, and now I have this expression right here. Also, there's a double angle formula here. So you might not be familiar with this, but if I have sine of 2 theta, I'll use a different, so I'll say sine of 2 beta, that's equal to 2 sine of beta cosine of beta. So I can rewrite this expression here, since in this case beta would be arctangent of 1/2. This guy is going to be equal to 2 sine of arctangent of 1/2 times cosine of arctangent of 1/2. Okay, so I have sine and cosine in here. So let's do a little bit more geometry to look at this circle. So let's look at this triangle with an angle of whatever this arctangent of 1/2 is. So what does that mean? That means that I have a 1 on this side and a 2 on this side. So since this is a right triangle, by Pythagorean theorem, I'm going to have the square root of 5 on this side. So this is my angle theta. So now I'm just asking, what is sine of theta and what is cosine theta? So this is going to be equal to 2 sine of that angle. So sine of that angle is going to be 1 over square root of 5 times cosine of that angle, which is 2 over square root of 5, which is then going to be equal to 4 over 5. Okay, so I have 4 over 5 in here. So this is starting to get a little bit convoluted. So why did we do that? So let's go back in time just a little bit. So we were trying to get our height up here. So we were trying to get this height. So 5 sine of alpha is actually going to be 5 sine of this guy, which is 4/5. So h is going to be 5 times 4/5, which is going to equal 4. Okay, so what I'm doing now is I have 1/2 base times height. So the area of this triangle is now going to be 1/2 my base, which is 5, times my height, which is 4. So 1/2 5 times 4 is going to give me 10. So now I have all of the puzzle pieces I need to get the area of that blue region. So remember, the blue region isn't our final answer, but it's on our way toward getting our final answer. Oh, sorry. Okay, so let's come back down here. So now that I'm looking at this, let's go ahead and re-look at this whole sequence right here. And let's try to organize our ideas just a little bit here. So let's bring that down. Okay, so we have all of our shapes here. And let's start off with this area of the triangle. So we found that the area of the triangle was 25. So this guy is 25. My area of my little boat was right here. So pi minus 2 arctan of 1/2 times 25 over 2. 5 over 2 times pi minus 2 arctan of 1/2. So far we have this minus this. Then we have the area of my little triangle, which is plus 10. Then we want the area of that little region that we found. So we found that right there. So it's 25 minus 25 over 4 pi. And that should give us the area of our purple region. So let's go ahead and simplify this just a little bit. So 25 plus 10 is going to give us 35. Let's come in here. Let's look at this a little closer. Okay, so 25 minus 25. So those guys are going to go away. So I'm going to be left with 10 minus minus, so plus 25 over 4 pi. Then here, I'm going to get minus 25 over 2 pi. And then I'm going to have plus 25 arctan of 1/2. Okay, so now I'm going to get, as my answer here, I have 10 minus 25 over 4 pi plus 25 tangent negative 1 of 1/2. Okay, and this is the area of my little region down there in the corner. So what I've just found is I found the area of region 4. So I started off, one of the first things I did was I found my area of gold plus that region 4 was 100 minus 25 pi, which means that my area gold is going to be equal to 100 minus 25 pi minus 10 minus 25 over 4 pi plus 25 tangent negative 1 of 1/2. And this is going to give me my final answer eventually here. So this gold region is now going to be 90 by taking this guy minus this guy. Then I have minus 25 pi plus 25 over 4 pi. So I'm going to get minus 75 pi over 4. That's from this guy and this guy. And then I'm going to get minus 25 arctan of 1/2. And that is actually going to be my final answer. So a little bit convoluted. We had to do a bunch of very interesting things with our geometry. Hopefully that was followable. And now that we have our region, we can look at this, and if we want to know precisely what it is, then it'll be about 19.5 is what that comes out to. So if we look back up here at our original shape, we can see that the area of these gold regions, even though the area of the total thing is 200, area of the little gold regions is 19.5. All right, so I hope you enjoyed working through that with me. If you did, please like and subscribe. If you have your own idea for a video, please submit it to thinkthriceproblemsolving@gmail.com. And as you're working through problems on your own, think once, think twice, and if you really get stuck, think thrice.